All right, good morning. Welcome back for some more Trig preview. As we're wrapping up the semester, once again, we want to just look a little bit at radians and how they compare to degrees. So hope you guys are having a good day. If you have any questions about any missing assignments or anything that you need to make up, please reach out to me. We still have about a little over a week left in the semester, but it's coming to close quickly. So please reach out if you have any questions about that. But all things will need to be turned in by the 15th. Okay, so make sure we get that done. Now, what is a radian? We already talked about this in our last class, but hopefully you guys remember. It is going to be the angle that's formed or the angle made when the radius is wrapped around the circle. Okay. And I'll show you once again a visual. So when the radius is wrapped around that circle, it forms an angle. Now, as we look at this picture here, and I'll go back to that slide if you need to get the rest of the definition, but here is one radius. So if this is the radius, if we lay that around the circle, this angle is 1 radian. We lay the radius again, that would be a second radian. We lay it again, that's a third radian. Lay it again, fourth, fifth, sixth, and a little more than 6 radians. Now, hopefully you remember from the other day how many radians fit around half a circle. Half a circle ended up being pi radians. So that's the same as 180 degrees, and the whole circle would be 2 pi radians. So if we think of the whole circle is 180, and there's pi radians. Remember, if we look at this visual, 1 radian is about, this is an approximation, but 57.295. It keeps going and going and going degrees. It's because we can take that 180 divided by pi, and that's what we get. Now, also, I want to point out, radians are in here. This is the angle inside. As I stretch this, you guys hopefully can see the radius. As the radius gets bigger, so does the radius length that we laid on the outside. That also gets bigger. The radian is there. It's the exact same. No matter what size the radius is, the radian stays exactly the same because it is an angle measure that will always be consistent on our circle. 1 radian will always be the same angle. Okay? And that angle happens to be around 57.295. Keeps going and going and going and going degrees, right? So let's go back now and talk about if we're converting each radian to degrees or degrees to radians. Okay, one tip, we learned these tricks, right? We learned how to go from radians to degrees and degrees to radians. Anytime we start off with degrees, we know we're going to end up in radians, which means the degrees has to cancel. If that is the case, then you know that the 180 has to be on the bottom because that's the only way degrees could cancel, which means pi will be on the top. Okay, so now I've got that set up. You can cancel out degrees. 120 over 180, if it helps you, cancel out those zeros. 12 divided by 18, hopefully you know that's going to be 2 over 3, so 2 pi over 3 is our answer. Now likewise, or I guess I should say conversely, on this one there's no degrees, which means we need to get degrees, which means when we write it, degrees will have to be on the top. So 180 degrees goes up top, the pi goes on the bottom. That's good. Another way you can think about it, there was a pi there. We need the pi to cancel. So pi and pi cancel. And now we have a couple options. We can reduce if we want, or we can simply pull up our calculator. Let me get rid of this so you can see the calculator. But if we just do 13 times 180 and then divide that by 5, and we get 468 degrees. Okay, on our last one on this first row, we once again have 75 degrees. This time it's negative. Remember, that means it would have gone clockwise if we were actually graphing this. Okay, or looking at a graph or a circle, unit circle. So negative 75 degrees. Now we need to multiply this. Degrees has to be on the bottom. So it'll be times pi. Okay, and now from here, degrees cancels. Now 75 over 180. It's kind of up to you on what you do. If you are having trouble finding one, just start with what's easy. Okay, so hopefully you know they both end in 5 and 10. 5 goes into this, 5 goes into 75 15 times. It's going to go into 180 36 times. Okay, now 15 and 36, those are both divisible by 3. So it'll go into 15 5 times, go into 36 12 times. And from here, we're left with negative 5 pi over 12. We are done. Now, our next one, 4 pi. If we have 4 pi, that's in radians. All we have to do here, 4 pi times 180 degrees. We need to get degrees on top, over pi. And once again, our pi's will cancel. And 4 times 180, you can use the calculator if you need to, or just know 4 times 180. You can probably do that in your head if you had to, or on paper, but you're going to get 720 degrees. Okay, so our next one, negative pi over 4. The pi is on top. We need the pi on the bottom to cancel. 180 degrees. We need to get degrees, so we know that goes on top. These are just the things I'm thinking as I'm doing it. Now, pi's will cancel. We know it's a negative. It's up to you. If you can do 180 divided by 4 in your head, go for it. Otherwise, pull up your calculator. 180 divided by 4 will give you 45. So negative 45 degrees. All right, as we look at this next one, 250 degrees. So 250 degrees, we need the pi over 180 degrees. So we know degrees need to cancel. So degree cancel. I'm going to get rid of the 18 and the 0 and the 0 there. So I think that's easier. Both are divisible by 10. 25 and 18, there's nothing we can do. So 25 pi over 18. Okay. So now the same approach, 318 here. If we start with 318 degrees, we know it's going to be times pi over 180 degrees. So once again, degrees will cancel. Now this one maybe is a little more challenging. 318, 180, can you come up with something that goes into both? Here's the deal. They're both even numbers, so just start with what's easy. No reason to make it more difficult. 318 divided by 2 is going to be 159. If you had trouble coming up with that, use a calculator. 318 divided by 2, you get 159. 180 divided by 2, that's going to be 90. Now, we're not actually done. 159, I know that's not a number we're that familiar with, but here's a trick. If all these numbers add up to be divisible by 3, then you know the number is divisible by 3. So 1 plus 5 is 6, 6 plus 9 is 15. 15 divided by 3 is 5, so we know 3 goes into that evenly. 3 goes into 15 3 times, and then it goes into 9 3 times, so that gives us 33. Meanwhile, 90 breaks down. That's going to break down to, I misspoke. 3 goes into 15 5 times, and it goes into 9 3 times, so 53. Meanwhile, it goes into 90 30 times, and from here, 53 and 30, we can think about it. 53, 30, there's nothing more that we can do, so we are done. 53 pi over 30 radians. All right, our next one here. We know it's going to be negative. We need the pi to cancel out, so the pi will be on the bottom, the degrees on top. Pi's cancel. Once again, you can just do 3 times 180. And then whatever you get divided by 5, just don't forget, we have to put that negative out front. So negative 108 degrees. All right, and our final one here, once again, we'll start, just take 135. We'll times that by pi over 180. Degrees cancel. Now from here, 135 divided by 180. It's up to you how you do it. Both of those are divisible by 45. If you couldn't think of that, start with 5 and work your way up. It's fine. You can do it either way. If you do it in chunks, either way, 45 goes in that 3 times, 45 goes into 180 4 times. So we'll get 3 pi over 4 as our answer. Now, down here, as we said, if it's 1 radian, that arc length is r. It's the same as the radius. That's for 1 radian. That's not always the case, though. Sometimes we don't always have a radian. Like here, the angle is pi over 3 radians. It's not even. So if I want to know what that arc length is, so right here it says for a circle of radius r, a central angle of theta. This theta just represents what is that central angle. So what is our angle in there? And subtends, that means the length along the outside that forms that angle. Okay, an arc whose length s is s equals r times theta. So whatever the radius is times that angle theta will give us what that arc length is. Now to do this, we could do it in terms of pi. We're going to actually find this arc length and round it to 3 decimal places. Okay, so if we look here, we have pi over 3. That's our arc length. And my radius is 2 feet. So all I have to do, it's already in terms of radians because it's pi over 3. So all I have to do is take that. Right here, you'll see it's the radius times theta. So in our case, the radius is 2. We times that by theta, which is pi over 3. And then we're going to round to, right here, 3 decimal places. Okay, so now to do this, I recommend using your calculator. Don't try to do it in your head. Now we're going to do 2 times, to get pi, hit the second key, and then come over here, this caret key. Do you see the pi right there? So 2 pi, and then you can just do divided by 3. It's 2 times pi divided by 3. Okay, and we get 2.094395102. It keeps going and going and going. So we're going to round to 3 decimal places, so 2.094. Now, on this next one, lots of you are probably thinking, just take 144 times 3. It'd be nice if it was that easy, but this formula only works if theta is given in radians. Right now we have 144 degrees. So the first thing we need to do is convert that to radians. Now, thankfully, we are good at that. Hopefully, on the front side, you remember, just do 144 degrees times pi over 180 degrees. And we'll see what that equals. So, once again, our degrees cancel. Now, 144 over 180. There's lots of things that go into both of those. The easiest option might just be to divide each of them by 2. That gives me 72. Which gives me 90 up here. Both of these you might recognize. They're both divisible by 2. You could do that again. I know they're both divisible by 9, so that drops to 8. This one will drop down to 10. 10 times 9 is 90. 9 times 8 is 72. 8 over 10. 2 goes in that, so down to 4. 2 goes in that, down to 5. So I get 4 pi over 5. That is how many radians. This is the same as 144 degrees. So from here now, all we have to do is take our radius, so 3 times 4 pi over 5. And we will get our answer here. So once again, I recommend using the calculator. 3 times 4, I'll go up here, second, hit the caret for pi. Divided by 5, we do all that, we get 7.39. Now, we round to the 3rd decimal place, so be careful. It's 398, which means we go up, which causes the 9 to go up also, so 7.540 is what we're going to get. Now, 7.540, and one thing I forgot to do on the first That was poor. I forgot to put my label. So centimeters for that one. This first one should have been in feet. The arc length is a distance. It's the distance around the edge of the circle. The radian is not a distance. The radian is an angle, okay, which we're calling angle theta, and that's most common. Okay, so let's continue. We got a few more. We're almost done here. If the radius is 10 feet, this time we don't have a picture. It doesn't matter. We know that theta is 150 degrees. Once again, that's in degrees. I need to get that into radians. So just take 150 degrees times pi over 180 degrees. Now from here, can cancel out degrees, zeros and zeros. And we're left with 15 over 18, which reduces to 5 pi over 6. 3 goes into 15 5 times, 3 goes into 18 6 times. So this is how many radians, okay? Theta is the same as 5 pi over 6 radians. So now from here, all I have to do, I know my radius is 10 feet, so 10 times 5 pi over 6. And whatever I get, that'll be S, my arc length. So I go up here, 10 times 5, hit second pi, divide that by 6, I hit enter, and I get 26.1799. Once again, if we round that fourth one up, it becomes, the next 9 goes up again, so 26.180. And our label here is feet. Okay, so this next one, pi radians, 38 inches. It's already in radians, so we can go the radius times pi times the number of radians. We're good to go. That was pretty easy to set up. 38 times, just do second pi, and we get 119.3805. So if we round up, 119.381, and this is in inches. So so that'll be in inches. Okay, we're just about done. This final question, after I looked at it, I wished I had worded it differently. I did not word this very well, but I printed this way back in November because I was trying to get the packets out quick. So sorry about that, but it says here, if Jasmine ran 2 radians from point A to point B, how far did she run? Now, what I meant to say is from point A to B, the angle formed here was 2 radians, okay? So if this here is 2 radians, then we're asking how far did she run? We're simply saying what is the arc length, okay? The same thing is what we want to do. Now, if its radius is 3 miles and it's 2 radians there, all we got to do is take the radius times the number of radians, which is 2. 3 times 2 gives us 6 miles. That would be the length of that arc length around the edge. Okay, so please get into It's Learning, complete the assignment. There will be one that's kind of asking you to do something a little backwards. It's kind of a challenge problem. Do your best on it. If you get stuck, please reach out. Hope you guys have a great day, and I will talk to you guys later.